For this video, we're going to have a little look at a past paper, paper 4 from Cambridge International Mathematics. This is series 0607 and it's paper 4 version 1. We also have a formula sheet displayed here. But let's get started. So question 1, these are 12 of Stefan's recent homework scores. So what we need to do first of all is put these in some kind of order, because we've got to find out the mode, the range, the median, the mean, and the interquartile range, which is probably the most difficult part of it. We've also then got a scenario at the end. So let's start with the mode. Now the mode is the one that appears the most often, so realistically we don't need to put them in any order yet. We can just count them up and say, hang on, number 18 has got 1, 2, 3 values there. Number 11 has only got 2. So the answer to that one would be 18, most often. Okay. Now the range is the biggest number, take away the lowest number. Well, what I'm going to do first of all is put these into order. So let's start with number 8. Cross that out. Number 9. And then there are 3 18s. No 17, but 3 18s. 18, 18, and 18. Okay, so we're going to have a little look at the range. Well, the range, as I said, is the biggest number, which is 18, minus the smallest number, which would give us a total of 10. So in here, the range would be 10. The median is the middle value. Now, because we've got an even number of numbers, there might be a number in between. If I put a line down the middle here, I would be looking at a number between 12 and 13. So that number there would be 12.5. Okay, the mean is obviously the average of all the numbers that are together, which in this case equals 159. If I add 8 plus 9 plus 10 plus 11 plus 11 plus 12 plus 13 plus 15 plus 16 plus 18 plus 18 plus 18, then I would get 159. I need to divide that number by 12, which would give me a grand total of 13.25. Okay, now the interquartile range is a strange one. What we're going to be doing is splitting it again here and here, because we've got, if we've got 12 numbers, we're going to divide these into quarters, and the interquartile range are basically the numbers here. A number between 16 and 18 and a number between 10 and 11. So in this case, we're going to have 17, and here we're going to have 10.5. So if I go 17 minus 10.5, then the answer should be 6.5. Okay? Now, the teacher wants to compare Stefan's scores with those of other students in the class. Explain why the mode is not the best value to use to represent Stefan's score. Well, Stefan's average score his mean average is 13.25. If we compare that with the mode, we know that the mode over here is 18. So if we're comparing Stefan's score with the mode, we wouldn't use it because the mode is the highest number, basically 18. So it looks like Stefan hasn't done very, very well. Okay, so that's the first question. Now the second one, we're talking about interest rates. Two banks pay interest in the following ways. Bank A simple interest at a rate of 2.5 per year for the first year, and then compound interest at a rate of 1.5 per year for each year after that. Then Bank B, simple interest at 1.6 per year. Cherry invested $3,000 in Bank A on the 1st of January 2016. So find out how much the investment will be worth on the 1st of January 2019. With question A, we've got a 3-year split. We've got from 2016 to 2019, which equals 3 years. So we're going to be working with this. But if we're looking at Bank A, it says that we've got an interest rate of 2.5 for the first year, but then this has been compounded at a rate of 1.5. So let me just swap things around a little bit. So if we look at this for 3 years, we have the formula 3,000, which is the initial investment. Then we're going to multiply that by 1.025, and that would be this here for 1 year. And then we're going to multiply that by 1.015 here. But that's over 2 years. Yeah, that must be over 2 years, because basically we're basing it on this here. So I'm going to square that number there. So if we put this into our calculator, 3,000 times 1.025 times 1.015 squared, we should get the number 3167.941875. Now, of course, we're working with money, so we would just take those numbers there and do it to 2 decimal places. So the amount of money is 3167.94. Okay. Now we've got another person, Dieter. Just going to swap my pen back. Dieter invests $3,000 in Bank B on January 2016. Find out how much investment will be worth on the 1st of January 2019. Well, again, we've got 3 years in here. Okay, and she's investing purely in Bank B. So the formula for this would be, we're going to start with that 3,000 initial investment, and this time we're going to times it by 0.016 for this interest rate here. And then we're going to multiply that by 3. Okay? But then we're going to add that. That will give us a figure for the interest, that there. But we're going to add that back to the initial investment. So if I put this into my calculator, I should get the answer 3,000 times 0.016 times 3, I should get a figure of 144. So if I add that to 3,000, I will get the number 3,144. Okay? Now, you might be thinking, why have I done this and put a 0 here when I'm putting a 1 on this one? Well, if I do it in such a way whereby I've got 3,000 times 1.016, then I will get the number 3,048. So I'm going to take that figure there and multiply that by 3. So 48 times 3, and I will still get 144, which I would add to that, which would give me that number there. Okay, that's those two. We've got 6 marks there, but we've got this one here, which is worth 4 marks. Okay, so that Sherry's investment will be the first to be worth 3,500. This is where it gets a little bit more difficult. I'm going to switch my pen colour for this one here. So let's have a little look at this. 3,000, and I'm going to times that by 0.016, times it by n plus 3,000, which should equal roughly 3,500. If I go 3,000 times 0.016 times n, I should get the 500. Times both those together, as before, we should get a number of 48. Times by n, we're looking at 500. So how do I get n on its own? N equals 500 divided by 48, which gives me a value for n as 10.42. So it's going to take 10.42 years to get my investment up to 3,500. 10.42 years. Yeah, that's Dieter's investment. But what about Sherry? So take Sherry's numbers. I'm going to go 3,000 times 1.025 times 1.015, and that's going to be my nth term there. I've got to work out how many times we're going to do that. So I'm going to take, times in both of those two numbers together, I've got 3,075, again, times 1.015n. Now, if I set n to be 2, I should get this number here. If I go, if n equals 2, then we know that that number is 3167.94. So what I'm going to do is, based on this, I'm going to take the number 10 here, and I'm going to put, if n equals 10, what is going to be my output? So let's have a little look at this. 3075 times 1.015 to the 10, I get a number, I get a value of 3,568.66. So that is significantly larger than 3,500. Okay, so therefore, in the case of mine, n is less than 10. Okay, but anything less than 10 is going to give me a bigger figure than the 10.42 years it's going to take Dieter to obtain 3,500. So Sherry's is the best one because n is less than 10 in Sherry's case. Now, the mark scheme might tell you something different, but that's how I would do it. I would take that figure there and I would plug it in here to see whether or not I'm going to get get a bigger or a smaller number. In this case, I've got a bigger number using the number 10, so therefore this is Sherry's investment is better. Okay, I'm hoping that makes sense. Going on to the next one. We've got a sequence. The nth term of the sequence is n squared plus 3n. Find the first 4 terms in the sequence. Okay, well that's easy enough. We're going to substitute n for 1. So let's go 1 squared plus 3 times 1 equals, so 1 squared is 1, plus 3 times 1 is 3, so the first term would equal 4. Okay, now let's replace these, the second term, so I'm going to replace those with the number 2, and that one with the number 2. So 2 squared is 4, plus 3 times 2, which is 6. So therefore the next number will be 10. This time I have 3 squared plus 3 times 3. So I've got 3 squared is 9, and 3 times 3 is going to be 18. And then finally, okay, I've got 4 squared. So 4 squared is 16 plus 12, which would give me a total of 28. Nice and easy. So that's the first one done. Let's have a look at the second one. These are the first 4 terms in another sequence. So we have 5, 7, 9, 11. So let's have a little look at this. We'll see if it's a linear sequence first of all. So I'm going to go, that's 2, and that's 2. These are the first 4 terms. Write down the next 2 terms. So basically we're going to go 2, and we're going to go 2 again. Well, 11 add 2 is obviously 13. 13 add 2 is obviously 15. So nice and easy, we've got 13 and we've got 15. Okay? So find the nth term in the sequence. We need to get to 5 from n equals 1. So if I take the 2 here and I say 2n, because we always put that is based on that number there. So 2n, and then what do we do next? Well, 2n, 2 lots of 1 equals 2. And what do I do to get to 5? Well, I'm going to add 3 to it. So let's check this formula to make sure it works. 2n plus 3. So if I plug in the second term, 2 times 2 plus 3, 2 times 2 is 4, plus 3 equals 7. So that's correct. And then I've got 2 times 3 plus 3. So 2 times 3 is 6, plus 3 equals 9. And of course, that's right there. So those are right. So we can carry on, and that's all good. So looking at that, I can say 2n plus 3. And that's our first 5 marks. Now then, of course, we've got quite an obscure one. But this obscure one is only worth 2 marks. Using the sequence in part A and part B, or otherwise, find the nth term in the sequence. So if we say the difference between 14 and 24 is 10, between 24 and 36 is 12, between 36 and 50 is 14. You see, this is a non-linear sequence. Well, for a non-linear sequence, if I'm just going to go down here and check the next one, so I've got 2 and 2. So this would be a quadratic sequence. So that can be written a n squared plus bn plus c. So we need to work out what these values are. Because we've got 2 in here, because it's 2, to get this term for a, we do 2 divided by 2, which is obviously 1. So we know that the first term is going to be n squared. Okay? So that's how we'd work out. If this was, for example, if this was 4, we'd divide 4 by 2, and then we'd know it would be 2n squared. But the value there is 2. Okay, so what do we do next? We've got n squared. Well, let's plug in n squared. So I'm going to come down here. N squared equals, let's start with the first value. Sorry, 1, 4, 9, 16. So they're the first n squared, 1 squared, 2 squared, 3 squared, 4 squared. But what I've got to do is I'm going to remove these. I'm going to take these away from these numbers here. So 14, 24, 36, and 50, which gives me numbers 13, 20, 27, and 34. I can see that this is 7, this is 7, and this is 7 here. So my next number in the sequence, this here, is going to be 7 lots of n. Okay? So we're going to work out what 7n is. So 7n, the sequence would be 7, 14, basically the 7 times table, 21, 28, 35. Okay, carry on and carry on. If I use these numbers here, yeah, and I'm going to take 7 away from that, I'm going to take 14 away from that, I'm going to take 21 away from 27, and I'm going to take 28 away from, 34, then we should see that we've got 6, 6, 6, 6. So the next number really would be 41 there. 6, not that we need it. So basically, I'm going to add 6 to it to get my final answer there. So for part 2, n squared plus 7n plus 6 is that quadratic sequence there. Okay, and that would get us our final 4 marks. This next question, we're looking at statistics. We've got some data that needs plotting on a graph. We're also going to be using the GDC for this as we get a little bit further on, and we're looking at this thing here. So the table shows the distance that each of the 12 students lives from school and the time they take to get to school. A. Complete the scatter diagram. The first 6 points have been plotted for you. So for 1 mark, we've got to put these points on. So we look at the distance 2.8, so somewhere down here, and then we move up to, for 2.8, we move up to 37, which is there, so we can measure that to there. I'll whisk through these. So as you can see, we've plotted the 6 new figures on there. So the next question asks, what type of correlation is shown in the scatter diagram? So we've plotted all the points, and now the next question is, what type of correlation is shown in the scatter diagram? Well, all the points are moving upwards as the distance is moving forwards. So with that in mind, we've got something called positive correlation. Now if all the if they were moving in sort of this direction and moving forward and moving downwards, then it would be deemed negative correlation. But because we could say that both variables agree, they're both going up, then it is deemed positive. So we now need our GDC because we've got find the equation of the regression line in the form t for time equals mx, x being the distance, plus c. So we've got to plot these into our GDC. So let's load the GDC, and we're going to be using one of the apps on the GDC, and it's going to be the one called Statistics to VAR. Now we've got to put all of our data, I'll do this quickly, I'll speed the video up. We've got to put all of our data, so that in this first column, in column 1, I'm going to put the distance, the x kilometres, and in C2 I'm going to put the time in minutes. So let's start with C1. So it's 0.8, enter, 1.1, enter, and then in the second column, 18. So we've entered all of our numbers in columns 1 and column 2. Column 1 being the distance, column 2 being the time. So the next step is to click on, we're going to come down here and we'll click on the, next to the apps button, we're going to click on the symbol button. We press that and we can see we've got C1, C2, and it's a linear sequence, and we've got the linear equation there, m times x plus b. So I'm going to press plot to show the plot, and I'm going to go back to symbol, and this puts in my figures. So you can see here I've got 10.5749 times x, the x, plus 5.70, and so on and so forth. So that gives me that value there. So taking that onto the answer sheet, I'm going to put these figures in. So I have, obviously, t equals, and to 3 significant figures, I've got 10.6 x in here, plus c, which is 5.70. And that would be my answer for that one there. Okay, so t equals 10.6x plus 5.70. Okay, now use your answer to part C, which we've got here, to estimate the time taken to get to school from a student who lives 2.2 kilometres away. Now 2.2 is a distance, and we've got an x value here, So I'm going to substitute my x for 2.2. So what I'm going to do is I'm going to go back to the GDC and I'm going to copy, I'm going to click on it and I'm going to click Shift and View for copy. Then I'm going to go back to my home screen. In the home screen I'm going to go Shift and paste what I've just copied. I've copied it twice, look. Paste what I've just copied, click OK. But then I'm going to go back using the sort of trackpad and I'm going to replace the x value. So let's backspace that with 2.2 for the kilometres. Then go back to the end, press enter, and I've now got a value of 28.967. Okay, I can write in here 28 point, and I'm going to put it 97. Okay, so it's going to take 28.97 minutes. Realistically, 29 minutes. Okay, so the final thing, why would it not be sensible to use your answer to part C to estimate the time taken to get to school for students who live 10 kilometres away? Well, if we look back at this, our range only goes up to 5.1. Okay, so it's a term called extrapolation, which basically means we don't know extrapolation. We don't know how the trend is going or progressing. It is outside the range. Okay, so that is question 4. Let's move on to the next one. Nice and easy, that one, if you know how to use a GDC. Okay, for question 5, we're going to be looking at areas, we're going to be looking at circumferences, radiuses, and also we're going to be looking at volumes. So the diagram shows a paper cup. The curved surface of the cup is made from a sector of a circle with a small sector cut from it as shown. So here we go. And the small sector has a radius, it's important, of 22.5, and the large sector has a radius of 32.5. The sectors of the same centre and both have sector angles of 45. So we're talking about these 3 figures here. Okay, show, for part A, show that the radius of the base of the cup is 2.81 centimetres, correct 2 decimal places. We're trying to establish whether this distance here is 2.81 centimetres. Ideally, in order to find out what that radius is, we need to find out what the circumference is here. Now the circumference, this bit, should equal the same as this distance here. Okay, so if you look at that, that is the bottom bit. Put an arrow like that, and then if I change the colour here, this bit is the top arc there, and of course these are the distance or the height of the cup. Let's go back to this. What I'm going to try and do is find out what the circumference is of the base of the circle, of the base of the cup. So circumference formula is C equals 2 pi r. Okay, that is our circumference. So what are we going to do next? Let's put these figures in here. So if I say the circumference equals 2 pi r, and I'm going to times it by 45, the angle of the sector, over 360. So that will give us just that distance there. Yep. So let's put this into our calculator. Of course, the radius we're going to be using is 22.5, which is this figure here. And then I'm going to put that into my calculator. So let's have a go. Okay, so in the GDC, I'm going to type in 2 times shift and 3 for pi multiplied by the radius, which we said was 22.5, and then I'm going to multiply that by, if I click on units, 45 over 360, and we should get an answer of 17.6714. Okay, so that is our circumference. So I'm just going to grab that and copy it. But what I need to do, the circumference is basically 2 pi r. I want to get pi r on its own. The circumference is basically 2 pi r. Now I want to get the radius, pi on its own. So if I take that figure there, 17.6714, and I divide that by 2 pi, I hopefully will get an answer, 2.8125. So if I go back to my question paper now, yeah, the answer was 2.8125, and of course at 2 decimal places, that would be that. So yes, that is correct. So doing it this way, and then dividing this 17.67 by 2 pi, yeah, I get a value of r, which equals 2.8125. Okay, just make my r a little bit neater. Okay, so that is the answer for A, working on that first sector there. Now, find the total area of the paper that makes the cup, including the circular base. So this, please don't forget this bit. This is where a lot of students make mistakes, include the circular base. So I need the area of a large sector minus area of small sector, okay, in the first instance. So I'm going to do that. I'm going to start at this end, 45, 360 times pi, but then I'm going to go 32.5, yeah, which is this one here, minus 22.5, which is this one here, and I'm going to plug that into my calculator, equals units, 45, 360 multiplied by pi multiplied, open brackets, 32.5 squared minus 22.5 squared should give us a total of 215.984, but that is only the large sector take away the small sector. Okay, we now need the area. So we've got the area of the sector, but we also need the area of the base. So area of the base is pi r squared. So I'm going to go plus, and I'm going to do this in brackets. We know that it's pi times, and we had 2.8125 squared, and if I enter that, that gives us a total of 240.83. So if I do that so if I round that up to 3 significant figures, I should get an area of 241. So pop that back into my calculator. So the area is 241, basically 241 centimeters squared. Okay. Now for the final bit, we're going to be doing some scale factoring. Now it does mention holding a mathematically similar cup holds 8 times as much liquid as the cup. So that's volume. Okay. 8 times as much. But it says find the total area of the paper to make the cup. So we're going to be using scale factors. Now we generally like to write scale factors if we have a linear scale factor, which basically is k. We have an area scale factor, which is k to the 2, and we have a volume scale factor, which is k to the 3. Now we're saying this is 8 times bigger, so because we're finding the area, we're going to be using the area scale factor, okay, which basically is squaring a number. So a linear square factor is just basically the original value, as for example 2, but the area square factor is 2 times 2, and of course the squared factor, the volume square factor, is going to be 2 times 2 times 2. So we're going to be using 2 times 2, which is a scale factor of 4. So I'm going to multiply equals 4. So I'm going to multiply our 241 times 4, and I should get an answer of 241 times 4. So I should get an answer of 964. Okay, so area square factor 2 times 2, 4. Volume square factor 2 times 2 times 2 would be a scale factor of 8. Okay, that's how we would work it out. Okay, area square factor. And that is it for that question. So I'll see you next time for the final part of this exam paper. I hope it's made sense. Thank you and bye for now.